Jai Hind everyone. This is Naresh Kumar from Ajay Kumar Garg Engineering College, Ghaziabad. Welcome to another class of Optical Communication KEC 058. So in this lecture, we will discuss the topic Introduction to Free Space Optics Based Communication System, that is FSO based communication system. Now the main contents for this lecture will be, first of all, we will discuss the introduction about the free space optical communication, sometimes also known as optical wireless communication system or wireless optical communication system. Next, we will discuss the block diagram of the free space optical communication system along with its main components. In the next topic, we will see some examples or types of free space optical communication based system. Then we will discuss the advantages of FSO based communication system. Then we will also discuss the main applications areas for the free space optical communication system. Then we will discuss what are the main challenges or what are the main limitations for the free space optical communication system along with disadvantages. Then we will discuss the performance improvement techniques, that there are some factors which are responsible for limiting the performance of free space optical communication system. Now to improve the performance of that system, we need to use some performance improvement techniques or mitigation techniques. So we will also list those techniques or discuss some, and finally we will conclude the lecture. So today's topic is optical wireless communication system or free space optical communication system. So in this lecture we will discuss the complete introduction and overview along with its challenges. So the main topic for this lecture will be FSO based communication system. This FSO based communication system is sometimes also known as optical wireless communication system OWC, or sometimes we also say that wireless optical communication system. Basically we know that in today's era there are two type of main communication systems. One is optical communication system, second type is wireless communication system. Both of these communication systems are very popular because of their advantages, but like any other communication system, no communication system is perfect. So to utilize the advantages of both optical communication as well as wireless communication, future will be the combination of the two, that is optical and wireless. That is, to gain the advantages of both optical and wireless communication, future will be new communication systems will be designed by the combination of both optical and wireless systems. The combination of these optical and wireless communication systems can generally give two type of systems. First type is known as optical wireless communication system, that is OWC, sometimes also known as wireless optical communication system, and another type is radio over fiber, that is ROF based communication system. Why we are combining these two? Basically we have to utilize the advantages. So first of all, for studying the introduction of this FSO, we have to see that in the optical communication system what we have is, we have an optical transmitter, then we have optical fiber as the channel, then in the receiver side we have optical receiver. Okay, so in the optical communication system we have an optical transmitter having some optical source like laser or LED. Then we have channel as a special guided media known as optical fiber cable. Then we have optical receiver. So this is the simple optical fiber communication system. The main advantage for this optical communication system is that we have very large bandwidth, and but along with the bandwidth there is limitation also, that it is a wired system. The main advantage is bandwidth, high value of bandwidth, and the limitation is basically it is a wired system. Second limitation is initial cost is high. High initial cost. Now if we compare it with the wireless communication system, in the wireless communication what we have is, we have a RF transmitter, then we have a channel, so as this is a wireless communication system, so the channel is basically, it is nothing but it is the free space or atmosphere. Okay, then in the receiver side we have the RF receiver. Okay, so this is the main parts of the wireless communication system, that is we have a RF based transmitter, then atmosphere or free space as the channel, and then we have the RF receiver. Now what are the advantages of these or limitation of this wireless communication system? Basically the main limitation is bandwidth availability or spectrum is very limited. Bandwidth or spectrum available is comparatively less. Then we require license purchase, license spectrum purchase, so these are the limitations. However, for the wireless system, being wireless system, as this is a wireless, there are no wires, so itself being a wireless system is a great advantage. So now in future what we require is, we require a communication system that can provide the advantage of very high bandwidth and still being a wireless system. Okay, so for such system we need to combine the optical communication system with the wireless communication system. So introduction to free space optical communication, also known as the wireless communication optical wireless communication system. Basically we have studied that in the future we want to take the advantage of optical communication while still being a wireless system. So we need to combine the optical system with the wireless communication system. So the combination will give us the free space optical communication system. So what we have in the free space optical communication or FSO based system, we have like an optical system, we have optical transmitter, then channel. In the optical communication channel we use is optical fiber cable. So in the FSO, instead of optical fiber we will use the free space as the channel, free space as channel or medium. Okay, because for the optical system we want to take the advantage of wireless. So channel is made wireless by replacing the optical fiber with a free space as the channel. And then we have the optical receiver. Okay, so in the FSO based communication system we simply replace the optical fiber channel by the free space or atmosphere. Okay, so this type of communication system will give us very high bandwidth and it will be a wireless system, and for this system we will not require no license or spectrum fees, no license or spectrum fee, as the optical carrier are a free spectrum, as we are using light as a carrier. So in the case of free space optical communication, the simple concept is that the wired optical fiber channel is replaced by the free space or the atmosphere, or we can say that optical carriers, light is used as a carrier signal. So simply the optical carriers are transmitted through the free space. So we can say that the optical wireless communication system, also known as the FSO system. FSO system refers to the transmission in the unguided propagation media through the use of optical carriers. So that is what we have shown in the diagram, that is, it refers to the transmission of unguided propagation media. That means here the propagation media is unguided, that is free space or atmosphere. Okay, through the use of optical carriers, that means light is used as a carrier, light is used as carrier. Okay, so using the light as a carrier signal through the free space or through the atmosphere, we can transmit the information. This free space optical communication basically is performed in the visible band, infrared region, IR region, or ultraviolet bands. So the main bands that can be utilized for free space or optical wireless communication system are visible band, infrared band, and ultraviolet band. Another point is about the optical wireless communication system is that we will use optical transmitter and optical receiver along with a wireless channel, or we can say that the fiber replaced by fiber is to be replaced by free space. That is, it is simply an optical communication where we have optical transmitter, optical receiver, but instead of optical fiber cable as a channel, we replace that with the free space or atmosphere, or optical carriers are transmitted through the free space, that is optical wireless communication system. As we have discussed, this FSO based communication system is also known as optical wireless communication system or wireless optical communication system. We prefer this optical communication system because it provides the advantages of both optical and wireless system. From the optical part, what we have taken is very large bandwidth, and from the wireless system what we have taken is that the channel is wireless. Okay. Next is, what are the main components or block diagram for the optical wireless communication system or the free space communication system? As we have discussed in the previous slide, the FSO based communication system is have transmitter part like any other communication system, channel part and receiver part. As we have discussed, this transmitter is basically in the FSO system is optical transmitter. Then channel part, we know that in the FSO system the channel used is free space or atmosphere. Then receiver part is simply a optical receiver. So first of all we will discuss the transmitter part. So in the transmitter part what we have is information signal or message signal that we need to transmit. This message signal is here in the digital form, that is it is a binary sequence. Okay. Then we use optical source here. As we know that the main function of any optical source is to provide light as a carrier signal, light as carrier. Along with this optical source will also help in performing the E to O conversion, that is electrical signal will also be converted into the optical form. Then another task that is performed by the optical source is modulation. And we know that in the optical communication system generally we prefer the intensity modulation, that is IM. So here is also the intensity modulator is used. So basically this optical source here used is laser. So laser is used as a light source or as a carrier signal. Then information signal is provided. Then according to the information signal, the intensity of this optical source is varied, that is we perform the intensity modulation. That is the intensity of carrier or light is changed in accordance with the information signal or message signal. For example, if it is a digital form, so message will have either 1 or 0. So corresponding to 0 we can minimize the intensity or optical source may be off, and corresponding to 1 the intensity may be maximized, okay, or we can consider the optical source as on. So this IM sometimes also known as OOK, which is equivalent to ASK in the digital communication. Okay. Then we have this transmitter aperture, then this modulated signal is transferred through the channel. Channel used here is free space or atmosphere. So because of atmosphere, there are a number of disturbances or turbulence present in the atmospheric channel. That's why this channel is also known as the turbulent channel, because the intensity of lights get affected in this channel because of various phenomena present in the free atmosphere. That can be, for example, atmospheric disturbances such as the snow, haze, raining. So these may affect. So on the receiver side, we have is antenna part, receiver antenna. Along with the antenna, we will have here is receiver aperture. Generally, the receiver aperture size is larger as compared to transmission aperture. Then we know that, like any other optical communication system, the receiver part of this free space optical communication will be optical receiver. So the first component in the optical receiver, we know that is a photodiode or photodetector. That can be PIN or that can be avalanche photodiode or photodetector APD. So this photodiode or photodetector will detect the received optical signal and will convert the received incidented optical power into the corresponding electrical form. So optical power will be incidented over the photodiode or photodetector and it will be converted into the corresponding electrical form, that is photocurrent will be obtained. And this photocurrent will be used for further electronic processing, that is here we can use is filter, equalizer, demodulator, okay, and conversion from one form to another form, decoding, conversion into the useful form. So electronic processing will be there. Now what is the main important part here is that this transmission aperture or FSO transmitter must be properly aligned with the receiver aperture. That is, we basically here use optical source and here we use the photodiode or photodetector. These must be properly aligned so that light intensity after propagating through the free space may be captured by the photodiode or photodetector directly. So we can say that the general observation is that this free space communication system is preferably a line of sight communication. That is, the optical source must be properly aligned with the photodetector so that light can be transferred from the optical source may be captured by the photodiode or photodetector. To ensure that this transmitter side is properly aligned with the receiver side, we use a system known as positioning and tracking system, both at the transmitter side as well as receiver side. This is to ensure this line of sight communication. If the transmitter part is not properly aligned with the receiver part, then there will not be proper capturing of the light intensity by the photodiode or photodetector and the performance of FSO communication system will also degrade. When this positioning and tracking system is not working properly or the transmitter and receiver are not properly aligned, then what we get is error known as pointing error. Okay, to ensure the better performance, the FSO transmitter must be properly aligned with the FSO receiver. This is another form of block diagram for the FSO system. Here we have the optical transmitter part. Here we have the optical receiver part. So the main limitation for the optical waste free space optical communication system is that we are using atmosphere or free space as the channel. Atmosphere or free space as channel, because the light intensity is greatly affected while propagating through the atmosphere or free space. So this channel is also known as turbulent channel, because its performance is mainly affected because of the turbulence effect present in the atmosphere or free space. So the main reason for the performance limiting of FSO based communication system is absorption of light. One is absorption, second is scattering of light, another reason is background radiation noise present in the surroundings. Then we have turbulence effect, that is intensity of light while propagating through the atmosphere is affected because of the presence of rain, fog, snow and haze. So these phenomena present in the atmosphere affect the performance of FSO based communication system significantly. This is one example of FSO based communication system. Basically this is the example of dual hop and a mixed system. Why we are saying mix? Mix means we are using both FSO and RF part, and dual hop means information is conveyed in two steps. Information is conveyed to user in two steps. First of all, we can see that this is the optical source or optical transmitter. This is another building where we have used the FSO receiver. This is FSO transmitter. Then we have channel as the free space. Then we know that the performance of FSO link is affected by the turbulence effect or various other effects like absorption, scattering, background radiation noise in the channel. So in the first hop, the information is conveyed from FSO transmitter to FSO receiver. So this system is FSO. Now to increase the range or to provide the signal to the end users, we have used this in between point. This in between node is known as the relay node. So from this source to relay node we have FSO system, and after that here we have obtained the signal with large bandwidth. Now this large bandwidth may be divided to many users in small parts, and for this part here we are using is RF link or RF system. So this high bandwidth is further divided or signal is provided to users using the RF signal. So in the first hop we are using FSO, and in the second hop we are using the RF or wireless communication system. There is another example. We are using a mixed RF and FSO system. What here we are using is this along with this FSO link, we know that the performance of FSO system is significantly affected by atmospheric turbulence, that is due to presence of rain, fog, snow and haze. So sometimes it can happen that due to the presence of these atmospheric turbulence effect, the signal received here is of very weak strength. Okay, or we can say that sometimes this FSO link may fail. Okay, so to continue the communication even in that condition where the FSO link fails, we can provide a parallel RF channel or RF signal that may be of low bandwidth, but this will ensure the communication even when the FSO link gets fail because of the high turbulence present in the atmosphere or free space. So along with the FSO we can have a parallel RF link or RF system with low bandwidth so that the communication can be continued. So what are the main advantages of FSO systems? These systems improve the system capacity. There is no requirement of license purchase or spectrum fee. These have very good reliability and initial cost of installation is very low. Operating system as compared to the other technologies. This FSO based system can provide design alternatives for extremely challenging aircraft to aircraft, aircraft to satellite vehicle communication. That is, this can be preferred for vehicular communication and sometimes for building to building communication. FSO can be used for both short distance as well as medium range applications. Basically the distance will depend upon the power used by the source. So that's all for this lecture. Thank you everyone. Jai Hind.